Hello, everyone. You're going to hear a voice of omniscience right now. Having a little bit of trouble starting my video, but welcome to MOS Live. Ask a Scientist Space, part of our MOS at Home programming. My name is Janine. My pronouns are she and her, and I'll be your moderator today. I'm really excited to ask some of your questions about space to our stellar panel of museum educators. If you'd like to see captions, you can go ahead and click on the closed caption button at the bottom of your screen and select show subtitles. We are so delighted to have you all here today as our audience, but before we get started, I'm going to go ahead and let our panelists hopefully be able to turn on their cameras and introduce themselves and their favorite image of space.
So my camera also cannot turn on, which is very interesting. It says the host has stopped our cameras. So maybe our host can fix that eventually. But the way that we wanted to introduce ourselves was by using, does it work now?
Looks like we're good.
Awesome. Thank you, host. So we wanted to introduce ourselves using some of our favorite images of space. So my name is Emily. My pronouns are she and her. And this is one of my favorites. This is an image of the Orion nebulas. So this is a small part of the Orion constellation. These bright stars at the top are the 3 stars of Orion's belt. There's a line of dimmer stars down here, which is Orion's sword, and near the belt and around the sword are those 2 nebulas. The one at the top is called the Horse's Head Nebula because it looks like a horse's head, and the one on the sword is the Great Orion Nebula.
Hi, everyone. My name is Eric. My pronouns are he, him, and the first image that came to mind when I thought about my favorite image of space was this one, which is Saturn from the Cassini spacecraft, which was a spacecraft that orbited the planet Saturn for a while. You can see the rings that up there at the top, and this tiny little speck is actually the planet Earth. So this moment was known that Cassini would be orbiting around the Earth, taking a picture of Saturn where Earth would be in the background, and NASA let everyone know. And so on this date, about 5 years ago, you could go outside and wave at the exact moment that this picture was being taken. And so I, along with a couple of people that I know, got to be in this picture taken from Saturn.
Hi, everybody. My name is Sarah. My pronouns are she and her. And my favorite image of space is one that is known as the ultra deep field. Now, this is an image that was taken by the Hubble Space Telescope, and it was actually taken of a part of the sky that if you were to just stand outside and look at it would look like a totally blank region of sky, but we basically pointed the Hubble Space Telescope at it for so long and let so much light come that we collected all this light from faraway galaxies, which showed us this, what is known as one of the great views of space. We have views of all of these different galaxies and all of these little images. These are stars in our galaxy, but anything that doesn't have these little crosses is something from outside of our galaxy. So one of my favorite images, just to think about how enormous space is and how much there is to see.
Thank you, guys. Those are some really cool pictures, some of which I hadn't seen before. I'm excited to get us started. For our audience, as your omniscient voice, I'll be fielding your questions using my voice, which you can submit through the Q&A tab here in the Zoom meeting. If you're participating with a child or another adult and want to share a first name and age when you submit your question, we'll love to give you a shout out if we do use it. And if you're joining us on Facebook, hello, thank you so much for joining us. Unfortunately, I can't see your questions at this time, but I am anticipating a lot of great questions from all of you. So go ahead and look in that Q&A tab. Oh, I like this question from Nico. Is Earth the center of the universe?
Oh, I love this question, Nico. And it's a natural question to ask. I'm going to start with the answer being no, and then shift to the answer being yes, because it's a little bit of both. No, there is no center to the universe. The universe doesn't have any edges, so it can't have a center either. I know that's a lot to think about, but our universe has no center, has no edge, and so therefore the Earth is not at it. However, there is one version of our universe at which we are at the center, and that is what's known as the observable universe. You could also call that the observed universe. When we think about how we observe the universe, we are in one place and one place only, with the exception of, the sun moving around the center of the galaxy, the Earth moving around the sun. For the most part, we're seeing the same view of space. All the light comes to us. And so from our point of view of the observable universe, yes, we are at the center. But the observable universe isn't the whole universe. It's just the part that we've seen.
Thank you. Robbie, age 9, wants to know how big is the Oort cloud?
It's really, really big. The Oort cloud is kind of the very outskirts of the solar system. So if you go out beyond the planets, out beyond Neptune, you get into some material called the Kuiper Belt. And that is some pretty big icy bodies like Pluto and a lot of other dwarf planets that are moving around in kind of a big disk, sort of like the asteroid belt between Mars and Jupiter, but further out and more icy because they formed further away from the sun. And if you go even further beyond that, there's even smaller bodies that are also very icy that can be comets, which have orbits that take them really close to the sun and then really far away, and they go really slowly, and they might take another 1,000,000 years before they come in and make another dive by the sun. There's a whole lot of material out there, and we think the sun's gravity is the dominant force all the way out to about half a light year away. So the Oort cloud itself is about a light year from one side to the other, meaning that if you lived on one of those tiny little objects and you sent a message to someone who was on the other side of the sun, it would take a year for that light to get all the way there. It's pretty big.
Huge.
That's really big. Gwen, age 9, would like to know, do black holes suck up stars?
That is a really cool question, and everyone loves learning about black holes because they're so fascinating. I do want to talk about that keyword that's in the question, which is suck. Black holes aren't actually like vacuum cleaners, and they're not roaming around the universe sucking up the things that they find. Instead, they kind of sit in their place in space, and objects could potentially get close enough to that black hole to be pulled towards it, because black holes have incredibly strong gravitational fields. So once an object, even if it's a ray of light, crosses over a certain line, like a certain distance, then that object or ray of light will start to fall into the black hole. So it is possible for stars to fall into them. It just means that they would have to get close enough to that black hole to make that happen. And I don't know how, does that happen often in space? Or is that a rare?
Not in our black hole, luckily. Yeah. When that happens a lot around black holes, if there's a lot of material that keeps on getting dumped into the black hole, then it can't, if it's a really big black hole, it has the chance of becoming what we call a quasar, which is basically when there's a black hole that's got tons of radiation spewing out of it. So luckily it doesn't happen often. Certainly not to small black holes.
Clement, age 9, would like to know, what is the difference between a comet, a meteor, and a shooting star?
So all those go together really well. So we start as a comet, and that is those really small, like I mentioned before, mostly icy bodies. They're kind of like dirty snowballs or snowy dirt balls. They form very far away from the sun, and when they come closer to the sun's heat causes some of that ice to turn into gas, and some of that gas gets expelled from the comet, and the comet leaves it behind. So what we see from the Earth is a really big, long tail of all that material that used to be part of the comet. We had a really cool comet that came by a couple of weeks ago. You may have been able to go outside and spot it with binoculars, or if you had a good sky, maybe even just looking at it. The best comet we've had in decades. So the part that we can see is all that material coming off of it. If the Earth happens to be moving around the sun and goes through some of that material that was left by a comet, then we get meteors, which happen when those tiny little particles, only the size of a grain of sand, hit the Earth's atmosphere going so fast that they make the air heat up to thousands of degrees and they make it glow. So when you look up from the ground, what it looks like is a big streak of light across the sky. Looks like a meteor. And shooting star is just another name for a meteor. So when we have a meteor shower, that means the Earth is going through a particularly dense part of the path of a comet where a lot of that stuff was left. And instead of just one or two here and there, we might get 1 or 2 meteors every single minute that you spend outside.
Yeah, I'm going to take this opportunity to ask you to define the difference between a meteoroid, a meteor, and a meteorite, because I think people get those confused a lot.
Yes. So meteor is when it's moving through the atmosphere, it's lighting up. Things are only meteors for seconds. Before they enter the atmosphere, it's a meteoroid. So the way I remember that is it's kind of like asteroid, which is a rock that's out in space. A meteoroid is something generally a lot smaller. And then if it survives through the atmosphere to hit the ground, we call it a meteorite. The way I remember that is a lot of rocks and minerals end in ite. And meteorite is a rock that's actually came from space. So you can pick up and say, hey, this is a meteorite. It used to be a meteoroid, then it was a meteor, now it's a meteorite, and I can put it in my pocket.
Thank you so much. Aditi, age 10, wants to know when the sun will have a supernova, and someone else asked, how old is the sun? So I think you can tie those together in.
Yeah, those are inquiring minds want to know what is the fate of our sun, and the answer, luckily for all of us, is never. The sun will never go supernova. Supernova is the name that we have for a particular event that happens at the end of a very large star's life. And it has to be quite a bit bigger than the sun in order to undergo what's called a supernova, which is basically when the star blows up at the end of its life. Now, all stars are kind of fighting a battle their whole lives between the force of gravity, which pulls things in, and the huge amount of heat that is made from a star's core pushing out. So they're sort of always balanced between those two things. Really big stars at the end of their life, it's gravity that wins. So basically there is not enough heat and gravity pulls everything in, it collapses and explodes. Stars like our sun, heat is going to win over gravity. So instead of our sun getting pulled in and then sort of exploding back outward, our sun's just going to kind of puff up like a soap bubble and lose the outer layers of its atmosphere, which will get larger and larger. And then we will turn into what's terribly named as a planetary nebula, but basically we'll just have a little bit of the sort of burning ember of the core of the sun, known as a white dwarf, and then just a lot of big, beautiful material around it in clouds. We're not going to go supernova. Either way, that's not going to happen for a long time. Our sun is not even middle-aged yet. We're in the prime of our lives here. Our sun is a fresh 4.4 billion years old, and we expect to keep on burning normally for another 6 billion years. And when the sun's about 10 billion years, that's when some interesting stuff will start happening to it. But it will not blow up, will not explode.
I'm going to give you this question just because I think it's a little tricksy, which is, could the sun turn into a type 1A supernova?
We don't have a companion star, so no. Did I do it?
You definitely
is
did.
1A from a companion star?
Yeah.
Is that,
Yeah.
Yeah. So sometimes two stars can be in a system with each other. They can orbit around each other like Tatooine, right? Luke Skywalker's planet has two suns in the sky. Sometimes if there are two stars very close to each other, one of them can have material from the other one pile onto it, kind of like black holes, like what we were talking about earlier. And that can be enough new material sometimes for a star that wouldn't usually go supernova to then go supernova. But our sun is not a binary star. We just have the one star. So no. Not this one.
They are really cool, those type 1A supernovas, though, because they're standard candles. So if we're trying to figure out how far something is away, the mass that falls on the star to make it that bright is always the same. All right. Could you explain what a white hole is from Mahiro, age 11?
Unfortunately, a white hole. So that a white hole is the theoretical something we imagine could be the partner of black holes. So this is something people thought for a while when we were first starting to understand black holes and how strong their gravity is. Some people got the idea that black holes are like the inflow of material in space, and that they might be connected, but that black holes might be more like a tunnel that just shoots material out somewhere else. So basically it's like a drain, that one end of it is the hole and one end of it is the white hole that material would shoot out of like a fountain. And there have actually been a few times where people thought they found a white hole. So that thing I mentioned earlier, a quasar, people thought quasars were white holes for a while. But actually so far, every time we found something spewing off lots and lots of energy, we have just found another black hole at the center. So white holes are theoretical. They do not exist as far as we have ever been able to find out.
All right, I'm going to tie these two questions together from Amy, age 8, and Ben. They want to know, how was the Earth made, and also how was the sun made?
So I can at least get this started. And I'll start with the sun, because I think that's where it all begins. Stars are born in these huge, beautiful areas of space called nebulas. And I showed you that image earlier today of the 2 nebulas that are in Orion's belt, or whatever, they're, you know, in the area of the Orion constellation. And these nebulas are huge areas of gas. And stars are essentially giant balls of gas. So to make a star, you need a ton of gas, and you can find that gas within these nebulas. So what happens is these small little particles of gas start to kind of drift towards each other because they are gravitationally attracted to each other. And then as that little, you know, thing of gases gets bigger, it gets a stronger force of gravity. So then more stuff starts to come towards it. And it's kind of like when you make a snowman. You start with a snowball that is small, and it gets bigger and bigger as you add more snow to it. So eventually that ball of gas gets big enough so that its force of gravity can ignite the gases in the very center of it and kind of start the process of nuclear fusion, which then creates all of that energy that is spewing out of the stars that we see in our solar system and the ones that we see in our nighttime sky.
Awesome. That was such a good description of how stars are born.
Thank you.
And talking about the Earth, if we were also talking about the planets,
Yeah.
as that pocket of gas is collapsing, other little pockets can form and start orbiting around, and they can collapse to form smaller bodies like the planets. And if there's pockets near those pockets, they can collapse and form into moons around those planets. That's how Saturn and Jupiter got a lot of their really big moons. Our moon was an exception. We think it formed just after all the stuff formed, when another body the size of Mars smashed into the Earth, and all that material got flung up into the air, and then some of it coalesced back into a solid body that got us our moon. So our moon, we think, has a really interesting history, different than the planets, how it formed.
All right, this question comes from Izora, who is 9. What is space?
So usually when we talk about space, it's beyond the Earth. When we talk about the vacuum of space, that means that there's nothing there. So when we walk around here on the surface of the Earth, we're walking through air, because Earth has enough gravity that it's held on to a lot of gas. Our atmosphere goes up about 62 miles before it really gets too thin to even fly a plane. Even then, if you go up a little bit higher to about 250 miles, where the space station is, in space, there's still enough air that there's some drag on the space station, and it will come down over time, and they have to boost it back up as they go around. So even though that's in space, there's still some stuff there. If you want to go really far away, say all the way in between the planets, or even between star systems where there's nothing there, a true vacuum where there's not even any particles at all, that would be definitely space. But the boundaries we have of where space starts and where it ends are a little arbitrary.
Thank you. Bella, age 6, would like to know, why is Earth our home planet?
Well, Bella, That's a really good question, because a lot of what we've been talking about in terms of how the planets formed tells you that a lot of this stuff formed at kind of the same time. And so the same Earth is made out of the same stuff as everything else in the solar system. So what makes Earth different than anything else? Well, there's a lot of things. There are some things we just don't know the answer to. We don't really know the answer of, when exactly everything on Earth started to evolve, but it seems like it was pretty soon after that thing Eric was talking about, when, something the size of Mars smashed into the Earth and made the moon. Seems like life started way back then. So really the question might be, why did everything work out so well? Well, it was hard to say, because there were a lot of chances for it to go wrong. But as of right now, the Earth is the only place in the entire universe that we know for sure is the planet that's the right size and shape and distance from its star, so that we're not too hot, we're not too cold, we have cool nights and warm days, and sometimes it snows and sometimes it's summer. There are a lot of places in the universe that aren't anything like this, and maybe we'll find something that looks more like it. But so far, the Earth is really the only place that life even could exist a little bit out of anywhere we found. So far, Earth is kind of your only option for a home planet. Maybe we'll find something different soon, though.
Another question we have is it true that there are super Earths?
Yeah, so we have found thousands of exoplanets, and those are planets that are going around other stars that are not our sun. So we've got 8 planets in our solar system, and we found over 4,000 of these exoplanets. And what we were expecting to find is star systems a lot like ours. So smaller rocky planets like Mercury and Earth and Mars closer to a star, and then bigger gas planets like Jupiter or Saturn further away. And the first one we ever found, or one of the first ones, was a planet much bigger and more massive than Jupiter, but much closer to its star than Mercury is. So that was an entirely new kind of planet. So we call that kind of planet a hot Jupiter. We found lots more of those. Another category that we found are super Earths. So planets that are bigger and more massive than the Earth, maybe 2 or 3 times the size, but still rocky, meaning they're not made of gas. They're not so big that they're a gas giant, but they have a rocky solid surface that life could evolve on. And they might be very similar to Earth in a lot of respects, but they might be a lot different. Their atmosphere might be entirely different, because with stronger gravity, they might be able to hold on to lighter gases like hydrogen. So super Earths definitely are out there. We have found a bunch of them. We don't know a lot more about them besides their size and their mass. We think we might know what their atmosphere is made of. We'll be able to find out soon with better telescopes coming online in the next few years. So it's a really exciting time for studying exoplanets and places like super Earths.
All right, now round this one out for the last one. Avery, age 7, is wondering, how is the sun a star?
So I would say that the biggest difference between stars and planets is that stars can make their own light, which is exactly what our sun is doing. In the daytime, we can see the sun and everything around us is illuminated. And it also provides our planet with thermal energy and the heat that we can feel when we stand outside in the sunlight. Anytime we see the planets in the sky, we're not seeing their own light. Instead, we're seeing light that is reflecting off of them from the sun. So let's see. I think that answers the question. Why is our sun a sun? Was that the question? I think so.
Yeah, and I
so
think
in general, it's because it's making all that energy.
And even just to add on to that, that really, even though it seems crazy because we look at stars and they just seem like these little tiny, usually white pinpricks of light that are tiny and so far away, whereas our sun is so huge and so bright. What's really amazing to think about is that every single star you can see in the sky, if you got close to it, would look just like our sun, maybe a little bit smaller and redder, maybe a lot bigger and bluer. There are different sizes and varieties of stars, but every single star you see in the sky is, so hot and so bright, just like our sun. Every single star could have planets around it, just like our sun does. So I think it's really, really amazing to think about, to think like, no, how could that be the same as all that other stuff? Is because all that other stuff, maybe there's solar systems and all those around all those different stars, just like our sun. So pretty amazing to think about.
That's really amazing. Unfortunately, it is time to wrap up today. So I'll invite our panelists to say goodbye and then mute your videos. Thank you guys so much for answering all the questions.
Bye, everyone.
Okay, now you guys get to see my face. Thank you again for joining us. We really appreciate you asking your questions. We hope you had some fun today. If your question didn't get answered, don't worry, we're going to talk about space again. You'll get another chance. You can see what other virtual programs we're offering by following the museum on our social media channels, or you can check out www.mos.org/mosathome. And if you enjoyed today's presentation and would like to support more programming like this, please visit engage.mos.org/welcome to support MOS at home. Thank you everyone for participating. We hope we'll see you again soon.